Okay.
Max raised.
Full screen.
So this section not only focus on the medical level, at the same time not focus on the technical level, right? Just we are given the guest lecture based on how to predict based on our health diseases. Okay. So first you should know what is mean by predictive. Generally, next to 20 years, AI will be treated as a human, right? Yes or no? How can you say yes? We are predicting some. How to predict? Based on the historical and current data. Whatever we are predicting any information, we are mainly focused on history and current data based on your future. Okay. So here, the predictive analysis mainly focus on why happened. Then, based on things, what is happening now, then we have to finding for what is happens in future. This is a flow only we are to focusing on predictive analysis. So how can you predictive analysis will generate based on a data. So you have a plenty of data. It depends on domain. Suppose I need only for healthcare. Based on the healthcare data, we have to analyze. Based on the analysis, we have to making for monitoring or processing to producing for the predictive. This area, people are affected this kind of diseases. Right? This is an example. We have to focus on this flow diagram. This is for leveraging AI, the predictive analytics in healthcare. So right from the early life to ending life, what are the phases we are facing, how our health we are focusing, right? All people are sitting here. Suppose I am testing for your heartbeat rate. All it should be same rate, it will be shown. It depends on your health. Okay. So this health is not a common based on your environment, food habit and your culture, it will be varies. So this is the flow diagram for the leveraging AI. Each and every, suppose this leveraging AI, it will be focusing on first thing is an early life. Then we can go for the economic status. Then you can go for geography. So each and every level, what is your health and how it will be projected. This is a diagram. Based on this, it will be identified. The AI will be generated to predict how much percentage of people are affected this disease or how much people are in a good condition. So it will be shows. Now let's go for introduction about predictive analytics in public health. So this session will be categorized 3. One is an introduction about predictive analysis in a public health, and second thing is an processing, and third one is an applications. Okay. So first thing is an introduction. In this introduction, the prediction is mainly focused on historical data. Based on the historical data, we are using some algorithm. We can using for any machine learning algorithm or deep learning algorithm. Generally, algorithm we are already known as classification, or you can using for supervised algorithm, non-supervised learning, and can using for reinforcement learning. So based on things, either you can using for the classification techniques or you can using the regression method. You can choose based on the problem. You have to choosing the algorithm to predict the values. So here, historical data, statistical algorithm and machine learning techniques. Here we have to specify which technique we have to find in the solution. Based on this, what we are going to find out? We have to focusing for the disease trends, identifying at risk populations and anticipating resourcing needs. The section we are not only focus on only for prediction. After predicted, what are the cases we have to secure and what are the resources available. We have to give the information to our public. This is a basic introduction about the predictive analytics. What are the importance in public health? Actually, there is two ways we have to give the importance. One is you can focus on morbidity. That means how much people are affected these diseases in a given population, or these are the area people are making an illness. This is called a morbidity. Second thing is an mortality. That is, we have to focus how much people are dead in a particular disease in a population. So the importance for our health is two way. One is an morbidity and second one is an mortality. Okay. One is we have to predict how much people are affected a particular disease. Another one is how much people are died in a particular disease in a population. This is a very important thing. And third one is an proactive management and mitigation. You identified this of people are affected a particular disease. Then what is the predictive method you have followed? Where it will go and find it out. So these cases are you are focusing on proactive management. Before that, we have to identify where you will go and take any treatment or what are the resources available, and all the cases are you have to give the proactive management. So any doubt for this? What is meant by predictive analytics and what are the importance of public health and what is meant by proactive management? Yeah. Nowadays, everything is growing, right? Not only that the positive side, most of the cases nowadays, the health issue is very, the medical miracle. Everyone forcing for provision, everyone, we are giving for the medical list in the, right? So how to predict? This is a way. The growing need for advanced outbreak management. So what are the ways we have to focus on? The first one is rising frequency of outbreaks. So here, how can you say this such of people are affecting for particular disease? Suppose in the winter season, everyone are affecting for dengue, or you can use it for flu fever. Suppose the summer season, some people are affected for chickenpox. How can you predict? Right? So seasonal diseases, or you can use it for the climate change, or you can use it for the globalization based on some fooding habit. So these are the case we have to focus on rising frequency of outbreaks. That's the first step. Second thing is an strain on healthcare infrastructures. Based on the things, suppose in our area, there is any availability, resources are available for the particular treatment. If it is there, and what are the tools available, and what are the recovery time. So each and every things you should be making. So the strain on healthcare infrastructure is we have to making for hospitals, shortage of medical supplies, and burnout among healthcare workers. These are the shortages. Okay, that is a strain. And third one is an early detection and resource optimization. So in this case, very important, we have to identify early detection. So in suppose nowadays most of the people are I having some many symptoms now, immediately no need to go for the hospital. Immediately you know the basic knowledge, just refer any I told our ChatGPT can use what are the symptoms, what is the we are predicting, right? இதுவா இருக்கலாமா இந்த ஃபீவர் நமக்குள்ளவே ஒரு expectation bayam ellame irukla. So we have to making for early detection for resources and optimization. So here you can focus on what are the detective method, early detection. So you can use it for vaccinates and medical personnel and diagnostics tests. So these are the cases you should avoid for the diseases. So these are the growing needs for advanced outbreak management. First one is in rising frequency outbreaks. Second one is in strain on healthcare infrastructure, and third one is early detection and resources optimization. Now we can focus on objectives for leveraging predictive analytics. So here first you should understand the tools and models. If you are going to predict which model you are using, I am using for machine learning algorithm. Based on the machine learning algorithm, I need to using for supervised learning. In this supervised learning, I need to predict for regression method. In this regression method, what you are going to find out? You can use several methods. So it depends on the problem, which tool we are going to use. So this is for understand tools and models. So here we have to focus on statistical methods. Based on the methods, we have to identify the machine learning algorithm. And second one is explore real life case studies. Even facing for COVID-19 is a very unforgettable. Yes, right? Everyone, this is a very, very important thing. The first life, how we have to suffer now, immediately we have to think in a COVID-19 manner. So here, the case studies, how will they be affected? So we have to predicting based on any dengue, or you can using for COVID-19, or you can using for any transmission forecast. And third one is evaluate impact on outbreak control. So here we have to focus on predicting analytics. The main thing, why you are going for predicting, it controls the diseases or you're not spreading to others, right? So here you can using for the effectiveness in reducing transmission rates and shortening outbreak duration and mitigating overall public health. So very, very important now, it will be affected. Then how can you avoid or spread to others? That is why you're going to predict. The last one is assess resource management. Here, what are the availability of the resources? So you can using for healthcare resources and medical suppliers, personnel and emergency services are available or not. If it is not, then where it will be occur. So these informations are your need to. Second thing is to understanding the dynamic of disease outbreaks. So here, first you should know what is a disease outbreak. Here the occurrences of disease cases. So you need to find, yes, you should know the endemic, pandemic, endemic, right? So you can using for pandemic means the disease spread in the continent or worldwide. Endemic means a particular area the disease will be spread. So like we have to finding the outbreak definitions. So it will be focused on population and depending on various factors. What are the type breaks? So here use for three. One is an epidemic. Epidemic means the occurrences of disease. It will be focused on a community in a particular time. That is called an epidemic. Second thing is an pandemic. It will be based on the any continent or worldwide affected. And third one is an endemic. It will be focused on any one particular area. That is affected the particular area now. It is called an endemic. And the last one is the transmission pathways. So how to transmit one person to another? Or it will be spread into some factor. So that is called transmission pathways. The disease transmit through various pathways. So what are the various pathways you can use for direct contact? Person per talk, some disease will be affected, right? So you can give some distance. And you can use it for the indirect. That is a format you can use it for dengue. This is an indirect contact. So these are the pathway. It will be transmission of the diseases. And how to evaluate on disease surveillance system. So here there are three methods are there, and finally you can give the limitations. The first one is an traditional methods. So the traditional method, historically what are the diseases are affected and how many hospitals are, how to recover, what are the duration, what are the medicines are, we have to focus. These are the traditional methods. Now role of global, second thing is a modern system. In this modern system, technically how we are increased to avoid reduce the diseases and how to recover the persons, right? So these are the case we are using for modern system. So here can using for the electronic health records and the syndromic surveillance. Nowadays each and everyone can use it with the smartwatch, right? Day to life, today what is your heartbeat, or can use a BP. You can checking for regular basis. We should have making some control for your food habit, whatever. If you need a suppose simply sitting in off an hour, then automatically it will be give a reminder, just move your body. So these are the cases you can using for modern system. And third case is role of global agencies. So here the World Health Organization and can using for the Center for Disease. So these are the two cases play the vital role to control the diseases and what are the cases to avoid, how to predict. So these cases are give the guidance. And the last one is a limitation. So here you can using for what are the challenges. If nowadays we have so many equipments are there, right? Advanced technicals are we can producing for the medical care, but still some challenges are remain. So you can using for how to avoid. So these are the cases we are focused. The transformative role of predictive analysis. So in the predictive analytics, what are the transformative role? First thing, you should identify patterns and trends. So these are the our student project, right? So a particular disease, how to identify, and based on thing, what are the cases we are predicting. I give the some output, identify patterns and trends. Here you can using for what are the data sets to uncover subtle for the patterns, correlation and anomalies that indicate emerging diseases. So you have to identify what are the patterns, what are the symptoms. That can go for identify pattern. Second thing is forecast outbreak likelihood. So here, based on the historical data and environment factors, we have to giving for predict the model can forecast based on the probability, intensity and timing for future takedowns. Okay. So outbreaks we are focused on probability, that is a statistical mode, and intensity and timing for future outbreaks. And optimize intervention strategies. So here we have to simulate the impact for different interventions. For example, for your vaccination. In this COVID also you can get the 2 dose, right? For if suppose you are going for any other state now, they will ask, are you vaccinated for COVID certificate? I think everyone is facing the problem, right? So like you can using for some optimized intervention strategies. You can give what are the resources allocation and allowing public health officials to choose the most effective and efficient based on the before deployment. So these are the cases for the role of predictive analytics. In this transmission the role, we can diverse the data, right? So you can diverse data sources fueling predictive models. The first thing is electronic health records. So you can give various wealth of clinical data. It's provide include the diagnosis, treatments, laboratories, results and patient demographic. So these are the things we have to understand the disease progression and identify what are the risk factors. That's the first thing. Second thing is in social media data. Here the publicly available social media data you can using for Twitter or Reddit based on the real-time insights into public health concern. So you can use it for what are the symptom reporting and community sentiment. They some cases the winter season they will show this particular area this much of people are affected for dengue. You can give the recovery action. So how can you get the information based on the social media? And climate and environment data. So here based on the environment temperature, humidity and precipitation and air quality significantly influence based on the spread of vector-borne diseases. The vector-borne diseases means you can use it for the dengue or malaria. So that is an other transmission of data. The last one is an lab test result of syndromic surveillance. So here you can use it for based on the symptoms, you can view the some identification and to producing for result. So here the symptoms reported in an emergency rooms are over the counter medication sales. So you can give the report, they will be affected or not. So based on the symptom, these diseases are affected or not, the information it will be given. Here the data quality. Suppose I have some data, how can you identify the data or quality data? So in this way, ensuring data quality based on your records. So each and every data, suppose you are using for data science, data analytics, business analytics, all should be based on data one. So if your data is a quality data, how to identify it is a data is a quality. So you can go for pre-processing steps. You know, right? Removing the unwanted space, removing the special symbols and what are the irrelevant information, so it will be clear. So we can go for ensuring data quality, handling missing data. Then cleaning and normalization and data anonymizing and privacy. These are the things already you are very familiar. When you are going for any pre-processing data, these are the important things. Okay. It's an advanced analytical tools for outbreak prediction. The previous data quality pre-processing, you are using for the normalization to reducing the anomalies. Everyone know the details, right? So I don't want to go for in depth. If you have any doubt, I will discuss. We'll go for the next. So this is for advanced analytical tools. So first one is, in this predictive analytics algorithm, we can either using a machine learning or deep learning. This is an advanced technique. So when you are going for the deep learning, they mainly focus on LSTM. LSTM stands for long short-term memory. So you can focus on RNN analysis. So these are the very flexible to predict the information. And second thing is a machine learning algorithm. Here you can focus on the support vector mission and random forest. And statistical models you can using for any method. Depends on the problem you can using for classification or you can using for logistic regression. That is a regression, you can have several methods, and a classification also we have a separate method. So unsupervised you can use it for any clustering algorithm you can use. So depends on the problem we have to identify. And the third one is fourth one is an spatio-temporal model. So here we have to focus on geographical location and time. So we have to predict the disease based on the condition, geographical reason and time, how much it will be spread. So it will be calculated. So these are the advanced techniques for outbreak prediction. This is the first section. Just a basic fundamental of what is meant by predictive analytics. Now we can focus on the predictive analytics in public health. Shall we go for the next second section, right? So this section we have to predictive the modern public health. So based on the real world case studies and essential tools. In this session we are mainly focused on case studies and essential tools. First one is a time series forecasting. So the time series forecasting, this ARIMA and the time series model, the example can use it for ARIMA, that is just to predict the future values based on the historical data. Then it will be trend the seasonally and cycles based on the environment, and it's crucial for to understanding disease progression over time. This was the ARIMA and PROBIT models based on the time series forecasting. Second thing is in flu trend prediction. So here you can use it for to analyze the historical data, flu data. So this historical data, flu is again it will be predict or it will be stopped. So that case we have to understand. And the second case study is for COVID-19. So early modeling efforts and mobility and case trends. So these are the case we have to give the response. Mobile netting, what is the response based on the case and hospitalization, and what are the resources, how much duration could be recovered. So these are the case we have to monitor. So we have some sufficient historical data, and mobility and case trends you can using for integrated into models based on to understand this is spread patterns, the symptoms, how it will be spread and how to predict the data. Then dengue fever. Dengue fever is a seasonal fever only. So based on the seasonal pattern prediction and weather and location data and reducing hospital overcrowding. So these are the case you can giving for the prediction method. So seasonal pattern, not only for the dengue, we can give several diseases. And weather and location data you can using for suppose rainfall, or can use humidity, and what are the cases, temperature, fever, right? So these are some diseases. And reducing hospital overcrowding based on the environment and spreading the diseases. So forecasting dengue cases, it helps manage healthcare resources. It reduces hospital overcrowding during the peak seasons. Then focus on the machine learning models. So here you can go for features and labels. So here the data provide features like a demographic and symptoms. So supervised learning method you can use here, label to indicate disease presence or absence. So machine algorithm learn from this data. And second one is a supervised versus unsupervised. Absolutely supervised, you can give the label, and without label you have to identify that is an unsupervised, and maybe a trial and error. This you can focus on RNN method. And evaluation is you can focus on the accuracy, precision, and recall. So you have to making for the evaluation matrices. And some deep learning approaches. So long short-term memory you can using for the networks, you can give the time dependent data and can focus on effective and forecasting disease trajectories. And image based detection based on the scans or any thing, you have to focus on the image based how they will be affected and how to recover. So these are the case you can using for any X-rays or can be for images. Then challenge. What are the challenges for deep learning approaches? Means you can use for interpretability of complex models to remain a challenge. So you have to ensure fairness and preventing bias are crucial. So here preventing is crucial to predict. So these are some dashboard, real-time dashboard. Here you can use it for the tools Power BI, Tableau, GIS. So here just to display your outcome with an geographical way. So it's Power BI and Tableau creates interactive dashboards. And this image itself can easily identify how much persons are affected, how much persons are rectified, right? So it is a visualized spatial data. So these platforms integrate diverse public health data sets. Second thing is a real-time outbreak visualization. So here real-time outbreak visualization is provide the dashboards. That it is one of the visualization output. So here display case count, locations and trends. So this enable immediate situation awareness of public health officials. That is in your mobile daily weather, right? If you're not for it will be shows what is the weather condition now and what is the traffic. So based on the things we are taking for the immediate solution. So that kind of information are can producing for real-time outbreak visualization. And the third one is an alert system. So here it provides for decision makers for critical changes. Automated alert can revert and give rapid response protocols. We are giving for the example for the smartwatch. Give the automatic alert for your health. And producing for early warning system. So based on your health, actually in our body is automatically early warning system is automatically. I don't know how many members are predicted. In your health, automatically give some processing for naturally. You don't want for taking for any medicine, but number one the health கேத்த மாதிரி யாருமே follow பண்றது இல்ல, right? So health is a very good processing for natural. So here the early warning system is can producing for to detect potential health threats. So they enable timely interventions to prevent outbreaks. Their importance lies in proactive disease control. So you have to focus on proactive disease control. And second thing is mobile app integrations. So you can giving some messages to deliver the warning. So this disseminate critical information rapidly to the public to ensure widespread awareness and preparedness. And the third one is an predictive analytics. So here you can focus on the various data sources for early signals. You can giving for anti-infectively public health actions. How it will be recovered. And this is for the example for the geographic information system. So mapping hotspot and based on the hotspot can clustering the analysis and to producing for geophysical forecasting. This is an example you can giving for some guidance. And this is for the resource allocation and management. So this is randomly we are taking for some data set. Based on the data we can giving for 20% of predicting hospital demand. So you can produce for hospital needs, that is bed and spaces and allocating for all the patients. So that is to ensure it's an adequate care. The second thing is 100K per vaccines distribution. So analytics guides efficient distribution of medicines and vaccines. It ensures supplies reach areas of greatest need. So this minimize the wastage and maximize impact. And third one is 15% of staff deployment. So here you can using for the shortage. So model optimize healthcare staff deployment. They ensure adequate personnel is affected. So affected regions. So it improves the response capacity based on the health emergencies. So the second case can go for health and public case studies. So third session can go for health care. How to predictive analytics in healthcare. So here you are focused on what are the applications and benefits and for your future potential. We will discuss about understanding among a healthcare professional and policy makers. So here the limitations of predictive models based on the data quality issues. Inaccurate and incomplete data can significantly skew predictions. If your data is correct, you can easy to predict based on the statistical model. If your data is not accurate, it's very difficult to finding the solution. So that is a data quality issues. Second thing is unpredictable human behavior. So here some human actions are complex and identify to predict. And third one is a limited generalizability. So here focus on it's not performed in new but unseen populations. It's unpredictable. The next section is for integration within public health policies. So what are the public health policies are available? First one is an evidence-based policy making. So here you can give for robust policy decision making. Second thing is an collaboration as a key. So data scientists and health officials must work together. That is an example WHO can produce for how the status, now the status for the particular disease are, how to predict the environment. And third one is an lockdown decision. Model predictions directly influenced COVID-19 lockdown strategies. And some emerging technologies are using in the predictive analytics algorithm. Here can go for IoT and wearable things. This example for the smartwatch can giving for real-time health monitoring and proactive care. And blockchain for data integrity, focus on ensuring secure and unchangeable health records. And last one is an AI-powered medical health. And future direction, we are focused on federative learning, multimodal data and community data. So here you can focus on how securely share data without centralizing it. So that we are focused on federative learning and integrated diverse data sources for richer insights, focus on multimodal data and engage communities in data collection effort. That is for community data. So these are the some summary of our predictive analytics game changers. So predictive analytics revolutionary healthcare. So everyone we have to focus on our health. Health is wealth. So we have to predict the diseases before. We have to take the proactive method. Okay. So real world impact is a tangible benefits are already evident. And adaptation is continuous learning is a crucial for your success. So this is for some recommendation sites. Invest in data. So based on the robust data, infrastructure reliability and trends, train professional and global collaborations. So this is for section for predictive analytics. Any suggestions and queries based on the predictive analytics? Actually, analytics we are studying for the data mining, data science, data analytics, and business analytics. So these are the things again you are studying for as usual machine learning algorithm, deep learning algorithm. Again, whenever you are going for any algorithm based on the statistical model, then supervised and supervised. So that we have to give for some different kind of algorithm. Okay, so you can easy to predict how much percentage or how many people are affected or not. If it is affected, what are the proactive methods you have to follow? So that is for this section. Thank you for all. Any doubts? Thank you.